Gyurek of Cisco. Russ is the Director of Innovation Labs at Cisco and has over 25 years of networking experience. His range of expertise includes optical technologies applied to networking, broadband architectures and related policy, emerging market development, and big data and analytics. He also serves on the FCC's Technical Advisory Council and chairs the NCDS Working Group on the Internet of Things. Today, Russ will focus on the Internet of Everything, as I said before, and that's defined as the intelligent connectivity of physical devices to drive gains in efficiency, business growth, and quality of life. The talk's going to last about 30 to 40 minutes, and then we'll have time for Q&A at the end. And feel free to type your questions in the chat box as we go along, but we're going to hold the questions till the end of the presentation, and then we'll read them back to Russ and let him answer some questions. So without further ado, welcome, Russ.
Thank you very much, and I appreciate everybody taking some time. I know it's lunchtime, so I appreciate this is probably your break for the day for those that are East Coast folks. I wouldn't mind changing it up a bit. I know you said hold questions to the end, but I have a lot of material, and I want to make sure I hit some of the key points. If there's 4 or 5 questions from the group that people want to submit right now, either type those in or unmute and just say, what your main concern is, and I'll try to, focus on that in the presentation. So if you want to take just a minute, if you have a question, send it right now, and that way I can try to hone in on those particular areas during the presentation. So I don't know if you get any of those fast enough or real time for me to be able to get some of those. So I want to appreciate I really appreciate the introduction, and I appreciate the opportunity to speak to all of you. And I'm going to hit some of the key concepts here today on IoT, but I'm also going to hit some of the key concepts on big data and analytics because they're very related. So just an FYI, there's some courses I'm supposed to be doing advertising as well, but there are some courses being taught this summer through NCDS that you can contact the folks that lead this meeting to get information on that, everything from an IoT course to our programming for analytics. So it may be a good follow-on if you want to dive deeper on some of these topics. So with that said, did you get any questions in yet? No questions? Let me just see, nothing in chat. Okay.
Yeah, we do, Russ, we actually do have one question.
Okay.
Primary concerns are security and ethical use of data collected by devices, particularly devices in our homes.
Okay, so I will be honest up front, I did not bring a ton on privacy, although it's near and dear to my heart. I will try to talk to that, so this is good I asked this up front. Okay. It is one of the uber topics that's quickly emerging, so we'll spend some time on that. And security, I look at these, by the way, completely different. Security and privacy are complete different items, and I'll talk a bit about security when we go through some of the tech stack. So let me jump in because I do have a lot of slides. So thanks for the question. So here's the quick agenda. I think I've already hit this. I am going to talk a little bit about mobility because, whatever you want to call it, really Wi-Fi, cellular, the wireless technologies are driving a lot of what's happening in IoT today, and I think that'll come out in some of the use cases. So I'll give you there's a couple quotes threaded throughout the presentation. And the short ones I'll read, the long ones I'll let you guys read. So big data is the foundation of all the megatrends that are happening today. Okay, so I think everybody gets that. My viewpoint is, to be honest, okay, let's talk about reality. It's also Internet of Things is at the top of the hype curve. Yes, there is a real hype curve that people track. This is the hype cycle of technologies, and it has replaced things like big data and wearable user interfaces. So let's keep that in mind. Hype doesn't necessarily always mean that it's the hottest or best technology. My personal view is it is, but we'll dive into that a little bit more. So let's talk a little bit about big data. What the heck is it? It's big, it's everywhere, it's all around us. You hear about it every day, but what is it really? And, to be honest, it's a broad term used to describe massive volume of both structured and unstructured data that's difficult to process or analyze with traditional software and database techniques. Okay, so you're probably still like, what is big data? That doesn't really give it to me. So I think that's going to come out a bit more in the next few slides, but it is driven by many sources, transactions, social media, events, process, and this big data term is a bit subjective. What we call big data today is probably going to be small data compared to tomorrow, and you'll see the growth rates of data. So you're all data producers, by the way, unless you're living somewhere probably in a barn in North Dakota, not connected to the network, not picking on North Dakota, but, every time you go shopping, use public transport, go to a web page, there's cookies on your machines, you're being tracked by your phone, you're participating in Facebook, in not even knowingly participating in many of these things, because most people, by the way, the question on privacy, all of you have user agreements when you sign up for a new app. How many of you read the 45 pages of text before you click OK, accept? Not many. So just be aware most of those things do track what you're doing. So big data, it is really the new norm. Some interesting stats over here on the left about how much data is, the one that's more interesting to me is by 2020, 40% of the data will come from sensors. And that's a massive amount because today most of the data is coming from Netflix, to be honest. So, that's a big change. Netflix is, video is a big traffic on, if you talk about the big internet. What's important here, though, is how data, data itself is, it's kind of like the new oil or whatever you want to call it. I have a great T-shirt from Cloudera that says, data is the new bacon, if you like bacon. So the problem is data is not very useful if you don't extract information or knowledge out of it. And to do that requires certain skill sets and tools as you move up the stack. And to make IoT successful, tying this back to IoT, you really need, you're going to collect a lot of data. But how important is temperature data if you collect 18 days straight of 67 degrees? That's not too exciting. So the key point is looking for either anomalies or what caused the temperature change or why did the temperature stay the same or something like that. The other interesting point here, just Walmart, how much they collect on a user per day. And we'll talk a little bit about Barcelona, which is a smart city, and it's generating terabytes of data per day. Okay, so again, a little bit of the basics and how we've moved from a traditional data management stack where you had more proprietary software, scalability based on those systems alone. There were standalone systems. There was consistency and completeness, very structured, relational and object data modeling. Now, what's changed is this volume, velocity, and variety of data, often called the 3 Vs, although there's anywhere from 5 to 7 Vs, and I think I even have a slide on that. But what's moved, we've moved into now is very large amounts of unstructured or semi-structured data. It's messier, parallel distributed processing, massive scale, high performance compute, in-memory analytics capabilities, and open source software and vertical software needs. And you've got these new players out there too to address that have gone out to look at how do I build a data center that's more fail-proof, that's more cost-effective than some of the proprietary systems. Not saying the folks on the left have not moved to that model as well. Many of them now, well, all of them now embrace Hadoop and are moving towards new technologies like Spark. Sitting on top of that, you still have the analytics that are very vertically focused. Now, what we're seeing in the industry is a very, very quick movement towards a vertical focused set of analytics tools because each vertical, when I talk about verticals in industry, something like retail, oil and gas, has specific needs that aren't just generic analytics. So that's where the new money is. And I think we can probably skip a couple of these. They're some of the basics, but I do want to talk a little bit about data science. I think most people get, what's really driving the data science discipline today is the data, the discipline of the study, which, my viewpoint in NCDS as a part of this is trying to put some parameters around what the title data scientists really mean. By the way, everybody you know on LinkedIn who's ever done anything with data thinks they're a data scientist. It's a very hot market, and we'll talk about that too. But it's really about discovery of data. I've got the 5 Vs. So I added 2 other ones because you have really variability as well as veracity, which is both, looking at the quality of the data as well as, how often or the variability of getting that data. So the other 3, I think, are very, common to most people in terms of the amount of data being generated, the different varieties, and how fast it's coming at you. And we'll talk about the real-time requirements, too, for some IoT disciplines. So some of the factors that are really changing this world are the amount of data, the availability of data. I mean, there's plenty of sites where you can download free data, which this may go to the privacy concern as well. But the government's, U.S. government's been pretty good about trying to make things transparent. Well, I have to say that with caveat on a lot of data. They do the opposite on some other data, of course. But, if you go to data.gov, you'll be surprised how much data you can access. And there's other companies that publish a great deal of data, whether it's stock market, crime data, Weather Underground has a great deal of data. I just wrapped up a project with some students on doing some comparisons, looking at correlations between temperature, crime, and activity levels, which was rather interesting. So all of this, is leading to this data science. Like I said, everybody on LinkedIn is a data scientist because this is the new sexy. This is the hot place to be. However, when you look at that, there's issues. That you still have too much data. There's still things that, processes that are too slow, too complex, or too expensive out there. And so the industry is really, trying to look at some of the tools to look. I want to cover this because people throw the term around analytics all the time, or BI, and machine learning is the new hot one. And I tried to put these in order, but it's really about, collecting data, looking at the reporting, and we'll go through a couple examples, visualizing that data, which is just part of being able to see it, taking the data and putting it into a visual format, and there's companies that excel at that. Add, the business intelligence piece, which you can do some business intelligence even from the visualization, but then the real cream to me is looking at the analytics, and that's where you do a deep dive on the data and try to pull things out other than just, looking at thresholds or limits or things like that, where you can even compare it with other data and contextual data. Then there's the vertical apps or the preventive maintenance type capabilities. I put PM as an example there. Preventive maintenance is very big, and you'll see that in some of the use cases. And on top of that, where everybody wants to get to is their nirvana of machine learning. Machine learning means my system actually, like for security, I know existing threats, but when I see a certain traffic pattern that I don't recognize, for the compute system to be able to say, that's really not normal, and that looks like a security threat, to be able to learn new threats. Now, a lot of people are somewhat uncomfortable with that, especially around security, because, you don't want to shut down traffic if it is acceptable traffic. So anyway, when you take a look at, you look at sort of the value curve of each one of these, from data ingest to data organization to visual, deep intelligence, and the process specific, you move up the value chain there. And it may be fairly clear to a lot of people how this works, but, this is really sort of the vertical progression as you take data from one end of the spectrum to the other end of the spectrum. And I think whether you're doing R or somebody's package that you buy, you'll see this sort of progression. Now, some companies stop at the visualization stage. Some companies stop at business intelligence. So just a quick view of what some of the basics are, visualization and reporting. You get some really pretty graphs, charts. It's not real insight other than you can look at this graph and say, well, there's growth, or, whatever that is. It could be growth or it could be bad if it's an increase in crime, for instance. But that insight is a visual insight. It's forensic in nature, i.e. it's after the fact. It really lacks correlation and causation, which are 2 critical components. Compared to when you pull up analytics, this is where you get the deep statistical analysis with a high correlation value. You can take, you can then feel confident providing a customer an SLA based on what you're doing with their data. It's more proactive. It can trigger actionable events. And sometimes it can even be close to the edge in near real time. I hate to use the term real time, but a lot of people do use, real time. But, you're not, you know, when you think about analytics and being able to process massive amounts of data, doing near real time becomes very challenging, and we'll talk a little bit about that as well. So we talked about some of the problems with this sexy new technology. So many of these have been solved with new technologies. For instance, too much data, Hadoop. And I would say the emerging one is Spark. You talk about being too slow, and what used to take days or weeks literally to process in the old grid analytics format, there's massive parallel processing, there's high performance compute. When we talk about too complex, there's in-memory, there's high performance analytics. And when we talk about too expensive, there's a ton of open source tools out there. And there's the BDAS architecture that's being driven by, you know, universities like Berkeley that came up with, you know, some of the Spark, the machine learning algorithms that are being developed, et cetera. And by the way, a lot of those, just on that topic, are being driven by what I would call, you know, the data giants, the Twitters, the Facebooks, the, you know, the Googles, who are really processing mass amounts of data per day. So, and I sit on this board for the BDAS group, and, you know, one of the comments I made to them was, you know, that's great if all your hammer looks like, or if all your data looks like, you know, a big data generic nail. But for IoT data, you know, it's a great hammer they've built, but for IoT data, that's not really the case. You have very vertical specific requirements that I think there's some additional needs. And they took that, and it'll be interesting to see if they embrace that as a change. But obviously, there's still a massive amount of data being analyzed, produced, or I should say cultivated and harvested by the Googles, Facebooks, and Twitters. They're the big sponsors of that. All right, so the coming challenge, and if any of you are students, I think this is what's more interesting to you. You know, some of the big data skill sets here, what's required to really get, you know, to drive some of these capabilities we talk about as a data scientist. There's primary skill sets in terms of, it should say NoSQL as well, but SQL, cloud compute, databases, distribution systems or distributed systems, enterprise software reporting, software development. I think this is a key, by the way. Development on a platform is critical, and you're seeing all the cloud players push for development. System architectures, vertical expertise, and then the actual, some of the programming services, I don't, you know, you can argue whether they're secondary or not. But the real critical here is we have a very big gap, and it's getting worse in terms of the skill sets that are available. When I said data scientists are the new sexy, they're going to become even sexier, and they're going to make even more money because it's just a very, very tight job market. And, you know, here's another view, a sort of view of some of the skills here. And this person right here with all those, the data scientist versus the individuals with some of those skills, becomes highly valuable to an organization. And I'm adding this IoT vertical expertise dude over here because those skill sets are now being added to some of these data scientist skills, because being able to understand how to apply that to an IoT vertical becomes very critical. So some of you may want to focus on the big buckets across the top. All right, so now let's shift into IoT. We've talked a lot about data and big data and analytics, or a little bit. Just a quick view here why, you know, this is the foundation of IoT and the networking and analytics, sort of a summary of what we just talked about. But from a networking perspective, and a lot of people say, why is Cisco interested in IoT, or why are you a big, you know, player in IoT? And I'll try not to make this too much of a Cisco talk. But what we see from the world of networking, 50 billion devices being connected by 2020. And we're pretty much on track with that, by the way. There's a transition, though, for a company like us from what used to be data transport to data intelligence. In the past, our customers drove us on speeds and feeds. It was always about, oh, we need more density. Oh, we need higher rates. We need better interfaces. We need 10 gig. We need 100 gig. We need 400 gig, whatever it is. You know, it's a constant drive. But now customers want data intelligence. It's like the data transport becomes table stakes. There's this emerging distributed architecture, which Cisco has coined the word fog. So it's like bringing the cloud down to the edge, i.e. trying to put intelligence closer to the edge. You know, it's almost like you had, not that the network was stupid, but trying to make it a little bit smarter throughout to do more coordinated actions. Also, you have the high performance compute capabilities. You're seeing networking, computing, and storage merge. In fact, on our platforms, you know, again, I won't give you the commercial. but the real-time event processing needs too. So you're seeing a lot of people say, I need this done at the edge. I need it done right away. And so that pushes a lot of the decisions to the edge as well as the compute capabilities, which makes it a challenge for certain products. The world of data and analytics has changed massively. They've had to move to HPA, to in-memory. They've had to move away from the grid of moving data to a cloud and operating on it. Big data doesn't allow that. It's too expensive to move data. There's a real-time capability requirement as well, or the need for speed. That's why they've embraced architectures like Hadoop. And there's the virtualized distributed data inputs that they have from multiple locations. And then, of course, a lot of this is being driven by the low-cost x86 processors that give them more compute power and intelligence. So taking a look at this digital disruption, so why is everybody so excited? And I'm going to let the dollar symbols speak for themselves on this slide a bit. You know, Cisco's predicted a $19 trillion economic worldwide impact. You know, you can see some of the other numbers here. You know, and that's not, by the way, that's not this year, the 19 trillion, that's over several years as well. But you're starting to see this big push because, and it'll come out in a couple of these use cases we'll go through, but there's a lot of money at stake here. There's a lot of optimization and savings at stake. So I'm going to stick with the fish theme here. So what is the Internet of Things? It's the network of physical objects or things that are connected to the Internet and generate data which create a service or greater value for the user, subscriber, manufacturer, operator, or other connected device. This is greater than just connecting things to the Internet. I want to emphasize that point. I know that's a mouthful already, but the real value here is, you know, it's not just about connecting things to the network. That's not Internet of Things. It's about doing the orchestration. It's about providing some capability with other services, features, applications, whatever, to either optimize or provide some type of overall service or solution. Also, this includes machine-to-machine, covers a large array of protocols, domains, application services. And my view here is there's going to be a multi-phase step that you see. The first step is, hey, let's apply Internet of Things and data and analytics to what I have today. And this is what you see from most of the industry players. It's like, I've got this process, and you think of these folks who have long-term depreciation cycles. Got this process in place. I want to optimize it. How do I do that? That's their first thing. The second piece is, wow, we optimized it, and we saved money. What new things can I extract out of that? Is there some new service I can do? Is there something additional I can do? And the third part is really transforming how they do that business. And we worked with a couple of the automotive industry players in manufacturing, and they're actually redesigning some of their manufacturing lines based on the data. That's a transformational activity. It's kind of exciting, at least to me. So a little bit deeper or more, you know, I think this is about the last slide where we talk about definitions here, but this really brings it home, I think, because it's about people, process, data, and things. Now, you could say people may not be the case with M2M, but in the end, it is about, you know, people are involved in most of these use cases, but it's really about connecting these together to provide, as I said, a solution. So, you know, it's delivering the right information, it's leveraging the data, it's connecting the things. And by the way, connecting the things is not easy. There's a lot of legacy protocols out there. The data has to be moved either into a private cloud or another cloud, into a certain database based on customer willingness or direction. And then you have to figure out what's the best applications or analytics to run on that, et cetera, and how to do the event processing. There's the privacy, there's the security, which brings us to this framework. So as you look at this across the industry and look at what needs to be done, you know, this is kind of the I would call it the blueprint. You have from the very bottom the physical devices and how they're connected. That's the edge. You've got that. Then you look at, there may be edge computing as you move up the stack after you get them, after they're connected. There's the data accumulation or storage. Once it's in the cloud there, you want to extract data from it. You want to run an application of some type, a reporting, analytics, or control process. And then you have your collaboration processes or services where you may do, you know, actuate a switch at the factory remotely, do some type of preventive maintenance action, you can think of multiple items you could run through this stack and work through it. This has been adopted by the industry leaders at IoT World Forum this past fall. We have a great deal of documentation and white paper around it. I can probably make that available to anybody who's interested as well to take a deeper dive. The one thing that somebody did, the one question up front, security is basically vertical across every one of these, by the way. And there was an interesting article today about encryption of data in, I won't name the company's cloud, but it's one of the big clouds, and how that's, they were able to do the encryption much faster, 2.5 times faster than previous, and it had very little overhead. Now, you're going to see more and more data be encrypted, go figure. But even in my FCC role, we're looking at what happens, because I'm focused now this year on the next-gen internet services and characteristics. One of the focus areas for us is the viewpoint we feel in advising the FCC that probably 90% of internet traffic in 5 years will be encrypted. And that creates some challenges for both service providers and vendors in terms of how to manage a network and so forth. But you're seeing this, and it's being driven by people like Netflix even, who, like I had mentioned, are the big dogs on data right now. But Netflix will have probably a good 35% impact on encryption data. So when we take a look at what's connected today and what's generating big data, because I'm trying to tie the IoT piece back to the data piece we talked about earlier, you looked at today there's probably around about 50 million smart meters, and you look at that and you're like, okay, 0.5 terabits, that's not huge. It's a decent amount. But then you take a look at a single consumer packaged good manufacturing machine generates 13 billion data samples per day. And that varies, and I've got a use case we'll go over. Large offshore oil fields generate 0.75 terabits, but refineries are 1 terabyte of raw data per day. And then the big one, and there's other ones like this, by the way, 10 terabits of data every 30 minutes of flight, which is incredible. That's a massive amount of data. And you figure out the amount of flights per day, you can figure it out. So we're talking about exabytes of data today. That's going to continue to grow, by the way. Exabytes is a relative term. And it's not really, it's interesting, we asked these questions. This is a Cisco survey we did from Cisco Consulting, but we asked this of our top, industry customers, what's the most important and relative needs? It's kind of interesting. It's not about the things. It's not about the people being able to, do their job. The real focus is around data and process and trying to capture and store and analyze data. Not that they don't care about these two things over here, just these are their big concerns and spend areas right now. And I think, the other change you're starting to see, shoot, I had another slide, but I think it's a little bit later. One of the big changes you're seeing, we talked about this, virtualization. As I talked about, big data means you can't just send data and move it around all that easily. So virtualization unites data from multiple sources. And, you really have to push some of the tools to the data. And this is the slide that talks about moving analytics to the data or to the edge. And again, this is one of the questions we asked our customers. 3 years from now, where will most of the data be generated, or where will most data generated by IoT solutions be processed? 37% believe most data will be processed at the edge. That's significant. That's a significant change because it's really less than 5% today. So let's talk a little bit about mobile, and then I'll move into some IoT use cases. I'm a little bit behind on time, but I'll try to catch up. This is from the Cisco Visual Networking Index. I'm not going to spend too much time on this. It's a very comprehensive report. It's well respected by industry. It is available for free download. You can check it out. It's a pretty long URL, but this will be posted later. So the real value with mobility is this real-time access to data. And it's interesting, when we work with industry players, they're equipping their plant floor guys with tablets and letting them use their smartphones, almost like a BYOD environment, to do some of these controls and access information. I'm seeing the same thing in farming and agriculture. You see farmers with tablets that are provided by vendors like Monsanto and John Deere. That helps them access data and be able to make intelligent decisions through a mobile network. And I think I'm going to skip this slide to hit a couple of the key points. So really taking a look, and some of these stats are just amazing. This is the report for 2014. Global mobile data traffic grew 69%. That's incredible. It's 30 times the size of the entire internet in 2000. Average smartphone use grew 45%. There are 109 million wearable devices. Okay, that's not that exciting. We need to see more, right, to get to that 50 billion. 46% of mobile traffic was offloaded to Wi-Fi. That's significant, by the way. Wi-Fi is going to be, I think, continue to grow, but also have some challenges. And the number of mobile connected devices exceeded the world population last year. And then what we're seeing through 2019 in our projections, the global traffic will surpass 24.3 exabytes per month. That's huge. The average mobile connection speed will be greater than 2 meg. Thank you, 4G, coming 5G. Let's see, a couple of the other really good ones here. Let's see, this is what gets me. 2019, there'll be 1.5 mobile devices per human. And then the Middle East will have the strongest traffic growth, which is surprising to me, 72% CAGR, which is, you have to wonder what's driving that. So a couple quick examples on the Internet of Things. It is everywhere. You guys are all familiar with these. These are really consumer-driven products, from a Fitbit to a Nest thermometer to a drop cam to some of the Wemo devices in homes. You've heard of these. I'm going to share some ones that you may not have heard of. So we are entering this new age of digital, or of quantification of self, whether it's Fitbits, whether it's a golf course app that you wear that tracks your drives, iron shots, and so forth. I mean, we are becoming censored. And my viewpoint, it won't be long before you can go to a store and either buy swallowable devices and sensors that will track, or be able to observe things in your system, or even, who knows. But I don't think that's too far off. Taking a look at some of the transformations and disruptions, Uber's a clear example of IoT in action here. It's transformed the taxi business, or the transport business. SenseMother, some of these are kind of cool. I just pulled up, that you're able to track different devices, or to these actually monitor some of the temperatures in different devices in your home, and you can pull data off them. The one I like is a smart ice cube that monitors how much you drink and how fast you're drinking. For those college students, this may be of interest. Skybell, this is a pretty cool one. It's an integrated doorbell with a video camera and a microphone, so you can, like, hey, what do you want? Somebody's at your door. You can see, hear, and speak. It runs on the mobile app. This is the one that I need, when I travel, to track my luggage anywhere in the world. It's kind of cool, and you see a lot of these apps right now on luggage tracking. This one's a little bit gross, the disposable diaper sensor. So it gives you data on, let's just say, the health of the, anyway. So the next one is the other one I need, because you attach it to a lot of devices that you lose a lot in the house, like your keys, your smartphone, and you're able to, well, you need your smartphone, I guess, to access it, but, it would come in handy when you lose different things around the house. So, or anywhere, but it's kind of cool. And some other ones that are kind of cool, smart sprinkler controls. Again, these are mobile driven. Smart propane tanks. I mean, there's pretty much an IoT implementation for just about anything you can think of. And smart garbage cans that tells when to empty the trash, when it stinks. It's good in the summertime around here. Delphi Connect. Again, this is the connected way of keeping in touch with your car. It's a mobile app that gives you access to a lot of the diagnostics on your vehicle. Anyway, so with that, hopefully you're convinced that everything's connected and generating new data sets. But there's a lot more, like the OxyClean guy. But wait, there's more, much more. So I'm going to dive in, and I'm going to probably be about, probably going to go to about quarter till, so we'll have 15 minutes for questions. What Cisco's focused on, or what I call, more of the industrial side. We're not focused on the consumer side. So I'm much more familiar with what's happening probably around manufacturing, transportation, utilities, energy, government, healthcare, retail. Those are the areas that we're focused on. And what's driving those are these really key technology areas of real-time, scale, smart data analytics, and security. Although I don't talk a deep amount about security in this presentation, as I said. So taking a look this might be why Cisco is focused on these opportunities, by the way. If you take a look at the industry size and the market money, as well as the degree of impact, our three top verticals are really transportation, oil and gas, and manufacturing. And, they're as well as, retail is emerging very quickly, by the way. And I'll end with an interesting article I just got this week on what retailers are doing. But you can see the relative value and degree of impact in each one of these IoT areas. It's fairly significant, but manufacturing, I wish I would have split, we would have split this out, energy and oil and gas, because oil and gas alone is pretty big. And by the way, some of these, they're large, but you have to keep in mind, too, it's a long cycle because some of these have 15-year depreciation cycles to get into, and it's not that easy to, you have to work with a lot of legacy systems. Quick note on what business leaders think. They think that nearly half of all processes could be automated. I'm surprised that's not a little higher, to be honest. But that's where you're seeing, as I talked about optimization and about automation. Earlier today, I was watching the news, and I think it's either Arizona or Nevada, I can't remember which, but they just approved a law for the tractor trailers to be self-driven in the state. So that's an optimization or an automated process. That one's a little scary, but they're saying the driver will still be in the car, but he just won't be driving. So it's kind of interesting. But anyway, you see a lot of disruption in this market for some of these. So I'm going to hit a couple of these use cases, and I'm sorry, I'm probably going to hit some of these a little bit quick just to get to some questions, and we can come back to some. We're working with, like I had mentioned, in manufacturing environments with some of the, whether it's the car manufacturers or other type manufacturers. Robotics are big. The new wave of manufacturing is all about robotics. And, so you can read what's new over there, but I think where's the value really is reducing downtime, rapid fault isolation, introducing new products quickly, consistent quality, and labor optimization. If you recall, for years, people didn't want to buy things made in the U.S., and I think a lot of that had to do, with some of the non-consistency of quality. As robotics and more process and control and IoT are implemented, you have much greater data in terms of was there a failure or how to pull that item off the market if you have to do a recall. The other thing is automating some of the manufacturing process. You may have like certain controllers that need to be upgraded. So this can all be done through IoT where you get this automated replacement order sent to a machine supplier. It's coordinated at the supply chain vendor through a smart fulfillment app. It's scheduled for downtime, and you have the lowest impact to your manufacturing cycle. This is IoT. This is huge for manufacturers. When you're talking about a manufacturing business of some, I won't name the company, but a large auto producer, and you save them 1%, that's billions of dollars. It's a big, big impact. Low percent savings or optimizations are massive, impacts in terms of the bottom line. Getting to more of a predictive maintenance, in terms of even fleet vehicles, you can reduce truck operations costs, reduce delivery, increase efficiency on delivery, times, reduce the delivery cost system, optimize some of the logistics. And a lot of that's done through sensorizing the truck, making sure that to avoid problems, before they happen. We have a deep dive on that. The other one that I'll share is connected oil rigs. These are really challenging because you don't have broadband backhaul. For the most part, you're dealing with satellite broadband. So, and you've got a lot of legacy SCADA systems. So you have to look at how do you do real-time alerts? How do I, because you don't have the time. These guys are drilling, miles under the ocean. And if the data has to be flown via helicopter to a land-based building for them to analyze and then, call them up and say, oh, yeah, go 5 degrees to the left, you've lost a day of productivity there. So there's a lot of capabilities in the massive amount of data coming from some of these oil rigs in the drill bits and how they're, exploring for new oil. Connected vehicle is one you've all heard about. There's a lot of saving opportunities around fuel, reducing accidents, also parking apps that are out there. I'm hearing some background noise. Does somebody have a question? Okay. Also taking a look at connected cars, this one's a little bit interesting to me. I got an article I was reading last week where the automotive industry is now looking at trying to put cars under the designation. There was a law passed back in, I believe it was 2009, on connected compute platforms that nobody is allowed to basically pierce the connected compute platform. So what they're saying now is you can't work on your own car, was what the article was coming down to, because it's considered a compute platform. For any of you who do it yourselfers, that's a little bit of a concern, but they have become, you know, very much a computer platform, multiple computers on a single car. You know, and the amount of sensors, and there's no doubt in the next 5 years you're going to see a much larger implementation of self-driving cars. Connected public safety vehicles, as well as, I would say, public safety personnel. I think it's been in the news enough in the last month, putting cameras on officers. But if you take a look at all the different devices that are in, you know, public safety cars today, everything from license plate recognition systems, they have printers. I recently had a little incident, unfortunately hit a deer, and the guy gave me a printout. It was kind of interesting. You know, so they've got a printer in the car, they've got GPS, video cameras, they've got all these different things. So they're basically a network on wheels. You know, and you could look at connected buses and mass transit. You could change this view into a train, but we're working with a lot of the transportation, the large train systems around the globe, and connecting up, trying to do preventive maintenance on wheels, efficiencies, et cetera. And I'm skipping through some of these a little bit fast because I have way too many slides. But the big one I talked about, and this is the super challenge, I think, is a smart city, because all the things I've really talked about, you're now combining on a city scale. And that's not easy. And I have to be honest, there's a lot of work yet to be done in these smart cities to get total orchestration. You know, everyone talks about, I think we even have a commercial out about the last traffic accident, you know, and the last traffic jam even. You know, I'm not sure that's going to happen in our lifetime. It's hopeful, but there's a lot of work that has to be done. But smart lighting saves millions of dollars. Smart buses, these are some of the, you know, this is the note from their deputy vice mayor about the savings and the quality. You can see the number of jobs that have been created, the new companies that have moved in, the amount of money saved on smart parking, smart water, smart lighting. It's pretty incredible numbers when you think about it. And there's dozens of smart cities in process right now. So just taking a quick summary here, you know, I think everything, just to summarize here, as we get to this 50 billion, I think you can realize now most everything that can be connected will be connected to the network. And the question is, how will that be orchestrated in terms of providing some type of, you know, services or capability? There's still big questions, obviously, on data privacy. In my view, it's the wild, wild west, and a lot of that's going to be decided by litigation, unfortunately. The FTC has issued guidelines. In the FCC role I had, we gave specific security statements and policy statements out, but at the end of the day, we told the FCC it's not really their purview to define privacy or security for, you know, for IoT devices, because that's not something that's under the FCC's control, really. It's not in their charter. But it is for the FTC, potentially, and other government agencies. So there's work to be done there. I talked about, as we've moved from megabits, and we're at exabytes today, you know, we're just counting, you know, zeros at this point. But we're going to soon be at brontobytes. This is a new term, in case I like my little Flintstone thing here I put in, because that's all I could think of when I heard brontobytes. But this will be our new digital universe of tomorrow, and you're going to see more and more, you know, data being generated. Right now, everybody's still at the stage of every bit of data is gold. I think we're going to quickly get past that, because there's some other issues that I think is a whole other talk for somebody to look at, you know, what the efficiency and the economic impact, and you could even throw in the climate impact of data centers are over as we get to brontobytes. Is there really a need to have access to all data all the time, and 3 copies minimum of it? So those are questions to ask too. This is the article I mentioned that I saw this week about retailers are trying to talk to you through light bulbs. So this one's really cool to me. I just think it's so cool. So we're very, very focused, and we're partnering with some of these companies here. But, you know, the connected light bulb gives you, it's kind of funny, most of the connected light bulb was being driven, we're doing power over Ethernet through smart switches to connect light, because LEDs are so much less powerful for enterprise applications. But now light bulbs can even communicate through visible light communication technology. This is not new, by the way. This is pretty old stuff, the VLC stuff. But it's giving you accuracy as well as direction people are facing much better. And this has been the challenge with retail. Most devices at best are 5-meter accuracy. You know, do the math, 15 feet doesn't help you much. You know, it's like what way is the person facing even? So this is incredible, and I think it's very cool. And then that's it. Open to questions.
Okay, we have a question here. Russ, I'm going to read this and let you take it then.
Okay.
This is from Stan Ahal. Given the incredible volume of data that is coming, has there been any discussion about creating metrics of value for data so that we can determine ways to triage data collection, transport, analysis, et cetera?
So it's a great question, and it goes to that, I think, the point, too, about the massive growth of data centers that's taking place. And it's good if you're a data center or a cloud company today. But there are a lot of tools that are emerging. The question gets to be, and my viewpoint is, the market will continue to address many of these issues. As we've moved from traditional databases, proprietary databases, to Hadoop-type infrastructures, to Spark. But to answer Stan's question, there's also some tools out there in terms of how to archive data, how to do more intelligent archiving data. And I think what we're moving towards with IoT, at least in our company, is doing some of the edge processing so that you don't send all the data to the cloud. What you need to send is maybe some of the, you know, I hate to even call it metadata, but a summary of data or only the anomaly traffic. Now, certain people, like I said, still want to collect every bit of data, but when they start to look at the economics now, the other problem is the cost of cloud just continues to decline. So it's like people are like, oh, it's cheap. I can afford to send everything there. So at some point, energy costs, you know, I think we're one of the few countries, by the way, that the cost of energy has not been a factor. I don't think that's going to stay static for, you know, for next 10 years. So, Stan, I do think there's a huge opportunity for people to focus on how to do more intelligent, what I'll call archiving, storage, how to have more, you know, quicker storage, retrieval even. You know, you look at a lot of data, it's scheduled data. You go to get your driver's license renewed once a year or whatever it is, your tags. Why do you need that on a hot server? You know, you have your annual physical. Why do you need that hot all the time? You know, well, yeah, if there's an emergency, I guess you do. So we need fast retrieval then. So you have these other challenges that come into play if you put data into cold storage or try to put priorities around it. Hopefully that answers the question.
Yeah. Okay, we don't have any more questions written down here. If anyone wants to unmute and just ask a question, now is your chance.
So this was a bit of a, you know, sort of generic overview on IoT. If you want to take the deep dive course, you know, doing a little bit of promotion here for the summer classes, NCDS has several, I think there's about 8 or 9 classes that are being offered in June.
Right. Yes, Russ, thank you so much for your time and for presenting all this very interesting information today. And as Russ said, if you enjoyed this talk, if you want to dive a little deeper, the NCDS and RENCI and the Odom Institute at UNC are hosting a short course series called Data Matters. It's the week of June 22nd, and you can go to datamatters.org to register for Russ's course or for any of the other courses that are going on as part of that series. And if you register by May 15th, you will get a bit of a discount on registration. Also, please remember that DataBytes is a monthly lunchtime webinar series, so we will have another session on Wednesday, June 3rd at noon. Our speaker will be Steve Gustafson of GE Global Research, so keep an eye open for more information about that talk. And anyway, I think we have another question. Russ, can you take another quick question?
Yep, and by the way, just to promote Steve's talk, Steve is fantastic. GE has some really great things they're driving both on data and IoT. So yeah, I would recommend people tune into that talk. So what's the other question?
Yeah, we do have another question from someone here at Renzi, from Dan Bedard at Renzi. Can you talk a bit about any efforts that are being taken to authenticate the source and processing steps and actors that apply to data from things?
Yeah, so authentications, there's several items that are very related here, and they're not the same, but security, identity, and authentication. And privacy is a little bit different matter, but the security piece is clearly a big one. So a lot of people look at security, part of the basis being able to actually either identify or authenticate that traffic. And as I talked about, Wi-Fi is becoming one of the big drivers. You know, the problem gets to be there's a lot of platform players out there, you know, in what I call middleware creation on how to ingest data. What I've personally seen is there's a ton of security holes. I mean, IoT clearly broadens the attack surface. You know, I don't know how else to put it. I mean, there's a ton of reports out there of people's insulin sensor or pumps being hacked, people's cars being hacked. I mean, not to scare people. I mean, it's just like those things have to be fixed. There's multiple frameworks that are being driven by both standards and consortia, whether it's the Open Internet Consortium or the Industrial Internet Consortium. The Machine-to-Machine group has, you know, as well as IETF and IEEE are trying to address some of the security concerns. The big problem that I want to state here, I don't have a clear answer of how to solve that because it is a giant topic and I'll just say issue today, or problem if you want to put it in that terms. Many devices are being produced that are stupid and long-lived. I mean, I don't know how else to put it. And that's how we said it to the FCC was, you're going to, you know, especially on the consumer market. And we're driven by, you know, cost typically when we make a purchase decision, you know, when we're buying something like a sensor or, you know, even certain devices. And to get the cost of your toaster down, if it's going to be connected, you don't want to pay an upcharge of $30 for this sensor. So you're going to see a lot of devices that are very, very cheap, probably manufactured in some other country or who knows where, and that could last for 10 years. So the problem gets to be once somebody figures out a hack, they're in, right? And so the question is, how do you apply security? And I'm very careful how I say this because I don't think you can truly secure things that you don't have control over. And this is going to become a bigger issue because, you know, companies like myself, we don't make things. So I can apply security to them as I move up the stack. I can secure the transport of that traffic, but that just secures maybe, you know, a denial of service attack or something all the way into the cloud. But, you know, the critical issue gets to be getting access to, you know, either, and we have a lot of companies out there that have registries that try to do that. I'm not personally a fan of registries because I think registries get to be too big. But long answer short is I don't have a great answer for you. There's a lot of work to be done here on authentication, and there's a lot of companies trying to solve that problem, including us. I mean, we have some things that we put in place. My viewpoint is the industrial market's much safer, and I hate to put it that way. It's just they're willing to spend a little bit more to get more than dumb devices, but still they're long-lived, and they're scared to death more about people hacking their Wi-Fi network. So the transport and the firewall is more important to them than the actual authentication of the things in the factory.
And to answer a final question that was here, yes, we are recording this talk and it will be accessible from the NCDS website where you went to log into the webinar, and give us a couple days or so to get that posted.
Yep,
So
and by the way, in the summer course, I'll dive deeper into the framework of how data is ingested, talk a bit more in detail about some of the ways that authentication is done. We'll talk about security being applied and different, different layers, because it can also be applied at the cloud. And we'll definitely talk a little bit about the privacy issues.
Okay, I think we've covered everything here. Again, Russ, thank you so much for your time. Again, people, don't forget about the Data Matters short course series at datamatters.org, and our next webinar is Wednesday, June 3rd. We'll be sending out some information and posting it in the same place on our website. Everybody have a great rest of the day, and thanks for tuning in.
All right. Thanks, everybody. Thank you.
Thanks, Russ.
Bye-bye.
Bye.
Thank you, Russ.